All right, so the first step in one of these questions is to write down what we're given. We're told the mass is 250 grams. Okay, we're looking for the number of moles, and we're told that it is water. Everyone with me so far? Okay, so we got to find the molar mass of water. So that's going to be 1.01 times 2, because there's 2 hydrogens, okay, plus 16, the 1 oxygen, and that's going to give us 18.02 grams per mole as a molar mass. Okay, now I need to find N. Do I need to change anything about the equation? Nope, okay, because the mole equation is already set up to find N. N equals little m over big M, our 250 grams, divided by 18.02. All right, so we're looking at 13.87 what? Moles. Okay, pretty straightforward on that one. That's the 3-mark question, right? 1 for your givens. Okay, 1 for the math, and 1 for your final answer. Okay. All right, give you a few minutes to try that one. So on number 2 here, they give us what? They give us the number of moles, so they give us N. Okay, is 27.25 moles. Okay, they ask us to find the mass, and they tell us we're dealing with calcium bromide. Okay, that's the kicker on that one. If I was to put that on a unit exam, I would bet at least 25% of people would forget to drop and swap that compound before calculating its molar mass, and as a result, we get the question wrong. Okay, I'm telling you that ahead of time because I want that percentage to be much, much lower than that on the unit exam on Monday. Okay, we always have to drop and swap our ionic compounds. All right, so we got 40.08, okay, for our calciums, and then we have 2 bromines, so that's 79.9 times 2. All right, so we got 199.88 as our molar mass. Okay, grams per mole. So now I've got to calculate. Okay, I've got to calculate the mass. So N equals little m over big M. How do I get little m by itself? Multiply both sides by big M. Okay. Okay, so now that's done. Now I can plug in my numbers. So I'll have my 199.88 multiplied by the number of moles, 27.25. Okay, and that'll give me my mass. Okay, so we're looking at 5,446.73 what? Grams. Okay, so that would be a 4-mark question. Okay, questions on number 2. Okay. Give you a few minutes to try that one. Now remember, anytime you have number of molecules, whose number will be involved? Avogadro's number. What is Avogadro's number? Times 10 to the 23. And what does it tell us? Are in a mole. Right. Tells us how many molecules are in a mole. Okay, all of these things are important for us to remember if we're going to do this question right. All right. So in this one, we're told the number of molecules. Okay, if I want to find the mass, I need 2 things. I need the number of moles, and what else? Right, the molar mass. Okay, I need the number of moles in the molar mass if I'm going to calculate little m, right? I've got to be able to multiply those 2 things together. Well, I can calculate the molar mass because they told me what I have. But the only way for me to get the number of moles, little n, okay, is to use the number of molecules here with Avogadro's number. Now, how do I use it? Multiply or divide? Divide. Right, I take this number, I divide it by the number in 1 mole, and I get the number of moles. Okay, so that'll be probably my second step after calculating the molar mass of lithium sulfide. Okay, so I got lithium with sulfur. -2 plus 1, so this is Li2S. Okay, so we got 6.94 times 2 plus 32.07. Is that right? Yeah. Okay. All right, so we got 45.95 for our molar mass. Okay, if I'm going to find the number of moles, I take the number of molecules I have, in this case 4.5 times 10 to the 25, and I divide that by the number of molecules in 1 mole, 6.02 times 10 to the 23. Okay, and what that's going to do is tell me the number of moles. All right? So, when we're entering those kind of numbers, they have to be in brackets, 4.5, and then I get the times 10, which is represented by an E, okay, to the power of 25, and then I divide that by Avogadro's number, 6.02 to the power of 23. Right, we get that I have 74.75 moles. Okay, so now I have N and big M. Now I should be able to calculate M, little m that is. So N equals little m over big M. If I want to get little m by itself, I got to multiply both sides by big M. Okay, so little m in this case then is going to equal 74.75, number of moles, multiplied by 45.95, which was the molar mass. Okay, and that should tell me the mass of that many molecules. All right, so the mass of that many molecules is 3,434.8. Okay, and what are my units? Grams, because this is mass. Okay, so that's also a 4-mark question. Sorry, that's a 5-mark question because you had to manipulate the mole equation as well as use Avogadro's number. Okay. Everybody with me so far? Okay, you got one type left. Now you're asked to find the number of molecules. So for number 4, again, number of molecules is mentioned, so we know we're going to have to use Avogadro's number for this one. Okay. In this case, let's write down our givens. First off, we know the mass. The mass is 500 grams. Okay. Since we know the mass and we know what we're dealing with, in this case potassium carbonate, okay, we have 2 out of the 3 parts of the mole equation. Right, which means we should be able to find fairly easily, okay, the number of moles. All right, so first thing we're going to do here is find the molar mass, okay, for potassium carbonate. Okay, so for potassium, what are we looking at here? 39.0. Okay, 39.10 on yours. Okay, grams per mole. Oh, sorry, we got to add that to a few other things here. Okay, how many do we got to multiply that by 2? Okay, and then we got to add it to how many carbons? 1. Okay, and then how many oxygens? 3. All right, so okay, we're going to have 39.1 times 2, okay, plus 12.01 plus 48. That's 16 times 3. Okay, so we got 138.21 grams per mole. All right, so there's our molar mass. Okay, now we should be able to calculate N. N equals little m over big M. How is N going to help me find the number of molecules? Right, if I know the number of moles, and Avogadro's number tells me the number of molecules in a mole, multiplying them gives me the number of molecules. Okay, so we'll have our 500 grams divided by 138.21. Whoop. Okay, well, we'll just make it 3.6, because that's all it'll, just makes it 10 times bigger. Okay, 3.62 moles is our answer. Hey, everybody all right with that? All right, so now I've got to take that number and multiply it by Avogadro's number to get the number of molecules. Okay, so that's going to mean 3.62 times 6.02 times 10 to the 23. Whoop, I guess I can't use that. 3.62 times 6.02. All right, so we're looking at 2.18 times 10 to the 24 molecules. Okay, and that's a 4-mark question. One for the answer, one for this math, one for this math, and one for your givens. Okay, ringing a bell for everybody. Okay, we need to become experts on this by the end of the day tomorrow, right? Because that is the end of this unit. Because on Friday, we'll be doing the unit exam review. All right, now, I want you to take out those worksheets and get them finished. Okay, you probably won't finish them today. That's okay. All right, but we're going to get them finished before the end of the day on Thursday. What do you suppose tomorrow's quiz will be on? Yeah, definitely. All right, so, hey, have a look. Now, while you are working on that, I am going to pass out your exam review package. Okay, and then I'll talk about that a little bit later on after you've had some time to work here. Okay, just listen up here, guys. I've had a number of questions on, it's 1B, right? Yeah, okay. Number of questions on 1B. When you do the calculation here for the number of atoms of helium that are in 2.5 moles, okay, it comes out on your calculator as 1.505 times 10 to the 24 atoms. And people are wondering, why does it suddenly bump up to 24 when Avogadro's number is 23? Well, here's why. You're multiplying the base of Avogadro's number, which is 6.02, by 2.5. Okay, when you multiply this by 2.5, you get 15.05, which is, if I want to put that in scientific notation, I have to make it a number between 1 and 9.9 for proper scientific notation. To do that, I have to take a power of 10 off of it and put it on to here. Right? So that's what makes it 24 and not 23. It's saying, look, this is actually 15.05 times 10 to the 23, except we don't write it that way. So we make it 1.5 times 10 to the 24. Does that sort of make sense? Just a math thing with scientific notation, whether you've taken math or not yet. Okay, that's why that works that way. Okay, any other questions on that sheet you guys want to go over? Which one? 3D? Okay, so for 3D here, we're looking for the mass of each sample. Okay, so the first thing we got to do is find the molar mass of magnesium chloride. Okay, so big M is going to be, what's magnesium here? 24.31. Okay, plus 35.45 times 2. Okay, so we're looking at what, 99? No, 100.21, is that right? Yeah, let's go 24.31, okay, plus 35.45 times 2, 95.21. Yeah, good thing we checked. Okay, so 95.21. Okay, all right, so there you go. All right. You need me to go through the rest of it, or are you okay now? Okay. Any other ones, guys? Don't be afraid to ask. All right, well, give you some more time to work on it then. Okay, listen up here for a sec, guys. Just want to quickly talk about that review package that I gave you earlier today. Again, you're not using class time right now to work on that. You might have some on Friday, or you can start it before Friday if you have time. That's probably not a bad idea to at least look it over. Okay, what you have on here, guys, are some suggestions for activities to do to practice some of your skills. Okay, for number 1, draw and describe the atomic models discovered in class. Explain why each was reasonable for the time it was developed and why it was actually rejected. So basically, read over lesson 1. Okay, read over lesson 1, look at the models, and kind of, have some idea as to why in general our idea has changed. Okay, describe ionic compounds. Okay, so how the ionic bonds work and how the molecular bonds work. Okay, so that's 2 and 3. Practice some naming. Okay, the key, there's answers on the key. There is a key for this on my website. I'll show you in a minute. Okay, write formulas for the following compounds. So again, practice some of your skills. Make up an example. That should be an example, not and example, of each of the 5 reaction types that we covered in class. So make one up. Okay. For number 7 there, write each of the reactions below in formula form and predict the products, balance the reaction. So again, practice some skill stuff. Okay, write a paragraph that summarizes the law of conservation of mass, so why we balance chemical equations. Okay, list the points of Dalton's atomic theory in your own words. Okay, some mole equation practice there. Okay, and then explain why the properties of water make it vital to all life on Earth. Make sure you look at lesson 8 about the properties of water and solubility. Okay, there are several higher level thinking questions on your unit exam involving the polar nature of water. Okay, things like that. Okay, so make sure you go over that. Okay, number 12 used to be an exam question. You have a solution with a substance dissolved in it that you want to remove. Explain how you could use a chemical reaction combined with your solubility chart to get the substance out. Okay, so you can think about it there. And then after that, there's some old multiple choice questions. I have not had a chance to build the key for this, okay? And I'm probably not going to. Okay, we've got the zone basketball tournament here, and I am slammed for the next 3 days. So I will probably not get a chance to get a key made up for that, okay? If I do, I'll put a little note in Google Classroom to let you know that I have, but I wouldn't expect it, okay? You should still be able to figure these out because you can look in your notes, okay, to find out whether you did them right or not on those. Or you can come and see me, okay, in scheduled help or something like that before Monday. Question? It's exactly like this. There's some multiple choice, and then there are some written response like this. Okay, it's going to look a lot like this. Okay, I don't change the format of my test, I change what's on it. Okay, so I'm going to have some balancing, just like this. Different questions, but like this. Okay, I'm going to have you predict and balance. I'm going to have you do some mole stuff. I'm going to have you do some, higher level thinking stuff like with the water and all that. So these are questions that were on exams in the past. Okay, and I'll tell you right now, when you open up your exam on Monday, it's going to look just like those multiple choice questions and these. The questions will just be different, but they're on the same stuff. Okay, the only thing that changes is the context of the question. That is how I ask it. So if I'm asking a question about a manipulated variable, I'll use a different experiment than the one that's in there. Okay? Everybody follow me on that? Something like that. So this gives you a pretty good idea of what you're going to see on your unit exam on Monday. So should this be part of your studying activities? If it isn't, you're crazy. Okay? Really, I'm giving you an old test to look at. It's not as long as your test, but it's basically an old test. Okay? I would certainly do it so you get some idea of how hard it's going to be. That's maybe not the right way to say that. How I'm going to ask things and what level of difficulty I will ask them at. Okay? And how I word things. So it gives you at least a chance to practice that and look at it. Okay? So make sure you include this as part of your studying for Monday. Okay? Questions on that? All right. All right, so guys, if you're looking for the key for that first page, go to my website, go to Science 10 stuff, same as always. Okay, and then go down to the chemistry folder, and down with all the other keys, there should be one that says Key for Chemistry Exam Review. Okay, so right here, if you click on View that, all right, it'll bring it up for most of them anyway. There aren't keys for the naming because, quite frankly, I think you can do that already. Okay. But there's keys here for the reactions. There's keys here for the mole equation stuff. Okay. Yeah, there's not necessarily keys for the explanation questions because that's stuff you're going to look up in your notes anyway. All right, so there's keys for some of it there. You can check it that way. Okay, real quick here, guys, just listen up. Good question just came up. If you're not here yet, okay, number 6 has a slight trick in it. Okay, number 6 is asking you how many oxygen atoms are in 64 grams of oxygen gas. But oxygen gas is a what? Yeah, it's also a molecule written this way, right? It's 2 atoms bonded together. All right, so there's 2 ways to do this. Some people figure out the molar mass of oxygen gas, O2, okay? And when you do that, you get 32, okay? So if you get that the molar mass is 32, okay, when you calculate the number of moles, okay, you're going to get a different number, all right? And then when you multiply by Avogadro's number, you're going to get the number of molecules of oxygen gas because that's what you've been dealing with. But what does the question ask? The number of atoms. So you have to take that number and multiply again by 2. Okay, because in every molecule there are 2 atoms. The other way to do it is to treat it like it's individual atoms, and instead of using 32, use 16. Okay? Then when you do that, you'll actually get the right number at the end. Okay? Everybody follow me there? So it's just a matter of all that question's asking. It's not even really a mole equation question. That question is asking, do you know the difference between an atom and a molecule? In a tricky way. Okay? That's what it's really asking. All right. Tomorrow, you have a quiz on the mole equation. I will post it sometime this afternoon. All right? That way, those of you headed off for basketball and stuff tonight can have a look at it before you go, okay? And or in the van or whatever, okay? So yeah, just make sure, guys, that you have a look at that, okay, tonight or tomorrow morning before class.